Good morning, this is Ms. Billerbeck. We're going to talk about 6.2 translations, rotations, and combining transformations. So right now we're going to talk about a translation. So the original object and the image of the object are congruent. So let's get two objects that are congruent. So congruent objects. Boom. Okay, so when we translate, we just move them like this, or move them like that. That's a translation. Okay, so every point on the object moves the same distance in the same direction. Okay, and the orientation of the object is always the same. Okay, that's the orientation. Now, if it wasn't the same, it'd be like that. Then they wouldn't be oriented correctly. But this is the same orientation. So this is A, B, C, D is mapped onto A prime, B prime, C prime, and D prime. That means it's been moved once. That's why we use the primes. By the translation of 5 units in the x direction and -2 units in the y direction. So we're just going to move this point C, 1, 2, 3, 4, 5, and 1, 2. So our new point there will be C prime. Okay, next we're going to move D. 1, 2, 3, 4, 5, 1, 2. So D prime is going to be right here. And if I'm going to move A, I'm going to move it 1, 2, 3, 4, 5, 1, 2. And B is going to be 1, 2, 3, 4, 5, 1, 2. So if you notice, it's the same shape. It's just been moved in a rigid transformation of translation. So reflection is also a rigid transformation because reflection also does not change the object. It would still be congruent if it was on itself. So that's from the previous chapter. So this is another rigid transformation, but it's just translation. Okay. So the coordinates of an image of point AB when translated h units in the x direction and k units in the y direction is given by A plus h, comma, B plus k. So h is the x direction movement, k is the y direction movement, and A, B are the original coordinate points. So if we have a translation T maps point 24 onto point 5, -2, and the point -49 onto point P. Describe the translation T. Well, first we need to see how far it moved to get from here to here. So we have our original point, T. So T was 2, 4. Then T became T, and we want to know the difference between, actually we want to know the difference between these. So let's look at how did it move from 2 to 5. So in the x direction we have 2 plus h equals 5. And if we subtract the 2 on both sides, we get h equals 3. And then on the the y's, we have 4 plus k equals -2. We subtract 4, and we get k equals -6. So now we can write, well, t prime is going to be a, well, actually, yes, a plus 3 and b minus 6. So that's how we would write the transformation. So we're going to add 3 to a, and we're going to subtract 6 from b. So now we need to find the coordinates of this p. Okay, so coordinates p. All right, so we started at -4. So p is going to be -4 plus 3 and 9 minus 6. So that's going to give us p as -1, 3. Okay, so what is the image of q at point 3, -1 under the translation of twice t? So that'd be twice this translation right here of plus 3 minus 6. Okay, so we could do it two ways. We could just translate it twice. So q prime would be one translation. So we're going to do 3 plus 3, comma, -1 minus 6. And that's going to give us q prime of 6, -7. Q double prime would then just be 6 plus 3 and -7 minus 6. So we have q double prime at 9, -13. Okay, we could have also just done q double prime equals and doubled the change. So it started at 3 plus 2 times 3, comma, b is -1 plus 2 times -6. And that would have given us 2 times 3 is 6, plus 3 is 9. Then -1 plus -12 is -13. So we would have gotten the same thing either way. All right, rotations, here we go. So in a rotation, the original object and the image are congruent. Okay, whoops, I'm rotating my board. Huh. Okay, so the image and the object are congruent. Okay, any point on A is moved through a fixed angle about a center of rotation. Okay, so if we have this, it's rotated about a center of rotation. Okay, think of a pinwheel when you look at these, okay? So it's going to act like a pinwheel. Then point A and its image A prime are equidistant from the center of rotation because they're running at their radius. Okay, so we're talking about radii, and radii are always equal. And the orientation of the object and that image are the same. Okay, so that's kind of hard to understand. Okay, that does not look the same. But if I keep rotating, it's going to line up with itself. Okay, now if I was dealing with a reflection like that, those would be slightly different orientations, the reflection. Okay, so if you can see the reflection there, let me see if I can do that well on here. So that's a reflection. Okay, so these orientations are not preserved. Okay, but the This one is preserved because it's a rotation. So it'll come around and line up with the original object again. Takes a little mind stretch there, but that's the way it is. Okay. All right, so let's go try this. So this is a fancy little protractor. Okay, so if I want to do 60 degrees, it's not going to be easy, to be honest. So I'm going to set this at 60, right there. Okay, this is my axis of rotation. So I'm going to rotate it about the origin. So I should have probably said that. Rotate about the origin. Okay, this is the origin right there. Okay, so now I'm going to take this object and rotate it 60 degrees. And actually, let's do this one instead of clockwise. Let's do this one counterclockwise. Okay, the reason being is I want to have some space. Okay, so I'm back to 60. I'm putting this on right here onto the origin. Okay, so I line up my first point here. Okay, so I have A right here at 1, so that means the new A is going to be right here at this one. And again, I have A in the way, but that's the letter A is in the way. All right, so then I carefully make sure this funny little protractor that's so awesome for this, I move it like that. And make sure it stays at 60. And I see, oh, that point's about 5.3. So about 5.3, I'm going to make another point. Okay. So then I hold it at 60 and I rotate it around to C. And C is about on my little measuring device right here. C is a little under 6, so I'm going to put this one a little under 6 right there. Okay, so now I can graph this, or actually draw this out, and draw my new triangle. Again, I am going to change where A is. Okay. So if we look at the angle of these points, so I can look at the angle right here and here. This little part here is a 60-degree angle. So this is my 60-degree triangle. So I have just rotated it a little bit counterclockwise. Okay? So counterclockwise is that way. Okay, so what if we take that, and this is going to be, if this was A, this is A prime, and that's B prime, and that's C prime. All right, so what if we move 90 degrees clockwise? So clockwise is this way. All right, so I am going to take this and move it over here because that's a 90-degree angle right there. That makes it really easy. And then I'm going to do the same thing with this B. So if I count 1, 2, 3, 4, 5, 1, 2, I count 1, 2, 3, 4, 5, 1, 2 right there. And C, if I count 1, 2, 3, 1, 2, 3, 4, 5. I count 1, 2, 3, 1, 2, 3, 4, 5. And now I can draw a 90-degree triangle rotated in a clockwise direction. Okay, this is where the points start getting really interesting, the coordinate points. So let's look at the coordinate points carefully here. Okay, so if this is A, and A was at 0, -1. Look at where A double prime ended up. It's at -1, 0. And C ended up at -3, -5. And that's C double prime. And B double prime ended up at, that was 1, 2, 3, 4, 5. So -5, -2. Okay, so let's look at these. So the original one was 0, -1, and this was just -1, 0. That's interesting. B was 2, -5, and this was the swapped ones, but now this y is negative, so it's -5, 2. If I had 5, -3, based on that, I'd expect -3, -5, and that's what I got. So it would seem that if we're going from clockwise, would be we swap them, and so this one stays the same. So we have B, -A. If we're going clockwise. Very interesting, huh? So let me write that down here so I don't get in the way of any other graphing. So that's going to be -A. All right, so now we're going to try 180. Okay, so this was my 90-degree one, and that's going to be clockwise, and this was counterclockwise. All right, so now if I go 180, well, that's just right here. And this one, 180, is one. We went 1, 2, 3, 4, 5, 1, 2. Well, that'd be 1, 2, 3, 4, 5, 1, 2. So that's going to be B triple prime. And this one was 1, 2, 3, 1, 2, 3, 4, 5. So we went 1, 2, 3, 1, 2, 3, 4, 5. Okay, so that gives us C triple prime. And I'm going to have to put B somewhere else because it's in the way. All right, so we have A triple prime right here. Okay, so let's draw the line, see what happened. Okay, and let's examine our coordinates. Okay, so this coordinate now is at 0, 1. This coordinate now is at 1, 2, 3, 4, 5, -2. And this coordinate here is at 1, 2, 3, 1, 2, 3, 4, 5. So this one's at -5 and 3. Okay, so let's look at our original. So the original one was 0, -1, but this one becomes 0, 1. Okay, the original B was 2, -5, and this is 5, -2, so the sign's flopped and the placement is flopped. Okay, this one here is 5, -3. Okay, so that should be -5, 3, so they should be flopped. Okay, so we should be flopped and negative. So let's look at what flopped and negative should be. -3, 5 would be flopped, and then negative. So I should be +3, -5, which is where I +3. Oh, I see what I did wrong. So sorry. Okay, so I should be +3, -5. So that should have been 1, 2, 3. Whoops, +3. 1, 2, 3, and -5. That does not make any sense. Okay, so they're flip-flopped. This is why rotation is so difficult. Okay, so let me make sure I've got everything. So rotation 180 should be AB goes to -A, -B. So let's see what's wrong. Okay, so it did not flop. Okay, maybe I did that wrong because it should. So we have 0, -1, 0, and that's, oh, this point here is not quite right. That's what's causing a problem. Well, that's -1, 0, but this point 0, 1, -1, that's, okay, so that's following this pretty good. So AB goes to -AB. All right, so that would make this -5, +3, which is where we were. So 1, 2, 3, and then we were over here, -5, +3. So we were okay. So everything was fine. Okay, this one was a little off because my coordinate was wrong. Oh, I'm so sorry. So that would be -2, +5. Okay, so that's a good way to check using these rules. Okay, so sometimes the rules are much easier than trying to figure it out the way I just did it manually. So that's why I really like these rules, and you can always use those rules on the test. Okay, so if we're doing 270, well, 270 is clockwise is the same thing as 90 counterclockwise, just saying. All right, so this one's 180. So let's mark it. All right, next, 270. So 270 is 90 counterclockwise. So let's erase the 60 because we need some space. All right, so this is going to be our first point here because we're going 270 clockwise, which is 90 degrees counterclockwise. And then if this one is 1, 2, 1, 2, 3, 4, 5, then we're going to go 1, 2, 1, 2, 3, 4, 5. Okay, if this one's 1, 2, 3, 4, 5, 1, 2, 3, we're going to go 1, 2, 3, 4, 5, 1, 2, 3. Okay, so let's see if I did that one okay. Let's see. Looks pretty good so far, but we'll check with the coordinates. All right, so we have 0, -1, and now we have 0, 1. This one is 5, 2. And that is B quadruple prime. I believe, yeah, that's B quadruple prime. And then this is A quadruple prime. And then C is right here, C quadruple prime, and that is at 1, 2, 3, 1, 2, 3, 4, 5. So 3, 5. Okay, so let's compare our original points. Okay, so this is our original shape right here. Okay, so we have 0 and then the y becomes negative. Ah, but you see what I did. Okay. This becomes 1, 0 because x goes first. Okay, so they swap and that becomes the negative. So if that's true, these would swap and the 5 would become positive. These would swap and the 3 would become positive. So we can say the rule here for this one, this double prime out of the way. Okay, so the rule is going to be AB is going to be negative BA. Okay. And that is the exact rule for 270. Wow, we're getting there. Well, 360 is pretty simple. It's AB goes to AB, so we're not even going to do it. Okay. And 90 degrees counterclockwise. Silly, that's 270 clockwise. Okay, so we're not going to draw that either. So this one's 270 clockwise, but it's also 90 degrees counterclockwise. Okay, so that's why we're not going to draw it again. Well, that was a tough one. Okay, you probably have to watch that one over and over again and go, oh, she forgot to do that. She did that wrong. Oh. So remember, never work in pencil. Okay. I mean, sorry, never work in pen. Always use a pencil. See, I made another mistake right there. Okay, so let's do combining transformations. So given T1 is a reflection about the x-axis, T2 is a rotation clockwise about the origin. Order matters, by the way. So T1, T2 denotes that this action is coming first. The rotation, T2 is the rotation. And then T1 is applied the reflection. This one, T2, T1, denotes the reflection is coming first. T1 is the reflection, and T2 is the rotation. So perform transformations from right to left. Okay? All right, so this one's all drawn out. So we just have to figure out what they did. Okay, so what are the transformations? So first we notice that this is A, B, C, D. And this one's A double prime. That means it's the second one transformed. Okay, so we aren't going from here to here. That would be bad. Okay, but we are going to go from here to here. So we need to figure out, well, what just happened there? So the orientation is the same. Okay, so that means that perhaps there's a 180 degree rotation. So what we can do is check the coordinates. So let's check some of these coordinates. So we have, this one's at 2.5, -2.5, and that's at -2. This coordinate here is at -3 and -1. And then this one here is at -1, -2. And then we have -1, -1. Okay, so let's see what's happening over here. So this one's at 1, 3. So A's at, so it's been swapped, and we have the negatives. So that's looking pretty much like a 180 degree transformation. So if we go back to what we were doing, AB becomes -8, -B. That's looking pretty good. Okay, then D. So D is at 2, 2.5. So this should be a negative. 2 and 2.5. Okay, so that's at 1, 3, 3, and that's at -3, 1. So they're swapped and made, okay, so they swapped and made negative. Okay, let's try this one. Okay, this one is now at 2, 1. So that's C. And this one's at 1, -1, -2. So it's looking like this transformation, AB, has gone to -B, -A. Okay, I have a handy cheat sheet here. Okay, so AB is negative. Oops, I think that one's backwards. Let's see my other one. Okay, so we have that. And we move that one to 3, 5, and that's 3, 5. So, negative B, -A. But that's certainly, okay, so let's look. So if we're not quite sure what's going on, that's what it looks like, is that it's a transformation. So when we don't know what's going on, let's get a little piece of this. And we're going to use that right here as our point of reflection, and we're going to draw it out with a little tracing paper. We're going to see, did the rule get written down wrong? Or do we have a problem with our coordinates? Okay, so we rotate with the little piece of paper. Isn't this cool? A little paper. Whoa, look at that. That is not a rotation. Okay, we have something weird going on. Okay, so it's not a rotation. I think I know what it is. This one is brand new. They didn't even come up with this one yet. Okay, let's look at this axis. So let's pretend that we had talked about this, but we didn't. Okay, but that's okay. Let's put an axis of symmetry like this. Okay, so we have an axis of symmetry that didn't quite go through the origin. But look, this looks equidistant from that. This looks equidistant from that. I think we're on to something. I think we are on to something. This was a tough one. Figure out what was going on. So if we draw a perpendicular line to that axis of reflection, what are we going to find here? Oh, what do you guys think? What does that look like to you? That is a reflection around the line y equals negative x. And why would you know that? Well, I think they were torturing you again with Singapore math, hard stuff from Singapore math. Okay, so that one is a reflection about this axis. Okay, so you wouldn't have known that. Okay, now how did we get to that? So let's look at how do we get from there to there. And we get our handy little paper here. And we see, oh, look at this. If I put that on the origin, look, that's a rotation. Isn't tissue paper awesome? You should all get like wax paper at home when you're doing this and try it. Okay, wax paper works really well. Okay, so now we have a 90-degree rotation. Okay, so we can say, ha, you didn't fool us. The first one, the first transformation is a reflection, not a rotation about y equals negative x. Because I know what that line is, even though I'm in Singapore Math 8. Okay, so then you can say the next one, the next transformation is a rotation of 90 degrees. And did we go clockwise or counterclockwise? Which way is this? That is counterclockwise. Okay, counterclockwise. There we go. About the origin. So you need to say that. About the origin. It's kind of important. Okay, the reason being is you could rotate other ways. So let's say I rotated just around that point. Well, that doesn't line up. So that'd be a rotation about about 1, 1 right there. Okay, I could rotate about this point too. So there's lots of ways you could rotate. So you really need to specify what is your point of rotation when you're doing this. Okay, so this particular one was a rotation about the origin. So that's how we lined it back up over here. So do get your tracing paper out, or wax paper or parchment paper, but make sure you get this because this will save you, okay? So our last few things, so we're going to combine transformations. So if we have transformation T1 is a reflection about the x-axis. Oh, we just did this. So somehow, sorry. got these out of order. Good thing I noticed. It's a long video. There we go. Okay, last one. All right. So this one we have M is a transformation about the y-axis. Well, that's much easier than that other one, don't you say? Okay, so and R is a rotation 180 degrees. All right, so what we're going to do is first we're going to perform R, the rotation of 90 degrees. Here we go. Let's do it. So if we move 1, 2, 1, 2, 3, 4, then we move 1, 2, 1, 2, 3, 4. Okay, so that's my manual way of doing it. Let's see if I did it right. Oops. No, I didn't. Did it right. So if you look at it like this, like a little anchor here, then we're going to do that like that. So it went up 2 and like that. Okay, so the new point's going to be here. Okay, so if you think about it like that, that's how it's going to be. So this new point ended up -1, -2. Okay, because this is my -1 and that's at -2. All right, so let's try that with this one. So this is going up like that. So we're going 1, 2, 3, 4, and 1, 2, 3. And we're going to move down here 1, 2, 3, 4, and 1, 2, 3. So we have 2, 3. Double check 1, 2, 3, 4, 1, 2, 3. And I'll just move this off a little bit. We'll do the coordinates at the end. Okay, this last one, we're moving 1, 2, so we're moving 1 on this. So we'll move 1 here, we'll move 1 down. So this is 1, 2, 3, 4. So from here, we're going to go 1, 2, 3, 1, 2, 3, 4. Okay, so hopefully we're going to have the same shape, but it's just going to be 180. All right, so this coordinate point now is -1, -2, and that one was B prime. This one here is at 1, 2, so that's -3, and we're 1, 2, 3, 4, -4. And that one is a double prime. Okay, so things are just becoming negative, that's all. So this coordinate here is at 1, 2, 3, 4, -4, and it's down just -1. So that's C prime right there. We're only on the prime, not double primes. Okay, hey, look, it's lining up pretty well because a rotation with the cheat sheet, which I will put at the end. So the rotation of 180 says it just changes the A and B to a negative. So we did a good job of rotating 180 degrees. And it doesn't matter if it's clockwise or counterclockwise, because if you rotate it this way or rotate it that way, it's going to be in the same place. So that's why we don't specify on 180. It doesn't matter if it's clockwise or counterclockwise. It's in the same spot, just on the other side. Okay, So now let's look at, it says perform MR. So first we do the rotation, then we do M. M is a transformation about the y-axis. But it doesn't say what kind of transformation. Y-axis. So let's look at what kind of transformation that was. So it looks like it's going to be a transformation like a reflection. So let me double check. So it says a reflection around the y-axis. That makes a big deal when you look at what is it. Okay, so this word should have been M is a reflection around the y-axis. Because they're all transformations, but we need a little bit more than that. So reflection about the y-axis. Okay, so we're here, and the y-axis is right here. So if we remember, they're equidistant. So if this is 1 here, this is 1 here. If this is 1, 2, 3, then 1, 2, 3, boom. If this is 1, 2, 3, 4, then this is 1, 2, 3, 4. Well, that was much easier. Okay, so this gives me B double prime, and B double prime's at 1, negative 2. Okay, C double prime, that's a C prime. Okay, so C double prime is at 4, negative 1, and D double prime is at 3. So 1, 2, 3, and then 1, 2, 3, 4. So negative 4, we had to go down. So that'd be A double prime. Okay, let's see what we see. Just the X is changing. That makes sense because that's what we know about reflections. Yep, just the X's are changing, and that's pretty good. Okay, now we have to ask ourselves a question. Would it have mattered in this situation if we had done a reflection around the y-axis first and then a rotation of 180? That's a good question. That's a question for this. So let's see. Well, we'll do as best we can with what we can trace. So forgive the former tracing. Let me try to get it at least inside of our thing, but I'm going to save tracing paper and save a tree. Okay. I'll go like that to make sure we know what we're doing. Okay, so if this reflected around the y-axis, it would have ended up here, right there. Okay, then if it had rotated 180, that would give us, let's use the rule, well, let's see, we have that, then it would have, hey, I think it's going to be in the same place. That's very unusual. So, so let's just go with 1 point here. So if that is negative 1, and that's at 1, 2, so 2, then we know a rotation is going to be at 1, negative 2. It is going to line up. So about that. So it's going to end up, oh, wait a second. Is it? Yes, it is. Okay, so let's try that again. I guess I should have labeled. So here's A, B, C. So we need to be careful that the points are lining up too. Okay, so we have B is right here. Okay, then B is going to come around here and be like that. Uh-oh. Is it going to do it? It is. Okay, so let's go back and double check because this is highly unusual. Okay, so if I have this one here, it would come down there. It is. This is really unusual, guys. So don't ever believe that this would happen under normal circumstances. Okay, so normally you can't switch these up. So these are the same, but that is quite crazy. So do not put that in your memory bank, okay? But it's only the same because this is a very special. It's the same. Okay, it's only the same because this is a special case. Okay, it normally will not be the same. So, okay. So the other thing I want to bring up is a congruent or isometric transformation. That's the image is the object. So let's say we did go and we went from here to here and rotated around here, and then we reflected over the y-axis back to here. That would be considered an isometric transformation or a congruent transformation, okay? Anyway, I have one more that I just want you to know. So you can freeze this and you can write it all down because I made all the little laws for transformation right here, just for you. Okay, because there's a lot to deal with, and I would want you to have this cheat sheet. Okay, so we've studied so far that a reflection AB becomes A negative B, and that's about the x-axis. A reflection about a y-axis is negative A. It becomes negative AB. A translation H units on the x-axis and K units on the y would look like this. A plus H, comma, B plus K. A rotation 90 degrees clockwise is going to look like this. B is going to become B negative A. A rotation 180 is going to look like negative A negative B. A rotation 270, negative B A. And I don't want you to lose a rule there. Okay, and then rotation 360, that's silly. That's silly, Miss Billerbeck. AB is just AB. Okay, and then a dilation by a factor of C is AB, and then that'd be AC times BC. Okay, so there you have it. These are all the transformations. Okay, the only one of these transformations that is not rigid is this one. This is non-rigid. Everything else is a rigid transformation. Okay, dilation is, if you want to see a dilation, that's where this comes in handy. Okay, this is a, let's see if I can do it with this little thing. See, that's a dilation where it gets bigger and smaller. Yeah, you can't really see it, but it's a sphere. Okay, too bad. Okay, so dilation is where it evenly gets bigger and not. So remember, to ask me when you get back to school, can I see your globe of knowledge and see it do a dilation? And I'll show it to you because this lovely little thing here, this thing, won't show it. It's not big enough to show my globe of knowledge. Okay, so there you have it. So make sure you write this down. This is an amazing cheat sheet right here. Okay, so write this down. Have a wonderful day. Bye-bye.